Hi class, in this assignment we're going to be looking at lines in space, and lines in space are defined as, well, containing one point, and then also they're going to have a vector associated with it. The vector happens to be in component form. All of these formulas will be given, and there's multiple ways of writing, in this case, a line in R3. Let me take a look at one problem so we can see multiple ways of writing the same answer. And on example 1, they're basically giving us 2 points in space and they want us to write the equation of the line. But for a line, we need a vector, and the vector has to be in component form. So in this case, let me just go back to the line and let me define V. So I'll say let V equal to the vector in component form of Q, technically minus P. So let me write it in quotation marks. So technically Q minus P, which happens to be the vector of 2 minus 4, comma, 3 minus 0, and then technically 1 minus 5, which is giving us the vector in component form of -2, 3, and -4. So that's going to be our vector. And then for the equation here, multiple ways of rewriting it. This is in essence your coordinate point, and that's your vector. So except that for the vector equation, they write the vector as either coordinate point or in vector form. I'll just follow the author, but both of those ways are actually correct. So in this case, we can say that the line L1, and let me just define it as R of t, and we're going to be using 405 plus the values of t, or v, and then -2, 3, and -4. I'll say using x0, y0, and z0 to be the 405. So 405. And then the proper format, it's as a vector. So 405, and then plus the values of t, and then -2, 3, and -4. Okay, so this is the proper one. You can express the point as a vector or as a coordinate point. So in this case, I'm following the author, and that matches completely with the proper formula given here as a vector. Okay, so let me double check. Okay, so that's actually it for part A. Another way to rewrite the same formula, it's in parametric form. So in parametric form, you're pretty much expanding the lines, and in this case, they want you to express it in this format. So you could actually say on this one that your x value is equal to simply 4 minus 2t. So 4 minus 2t. Your y value, it's going to be 0 plus 3t, or simply 3t. Your c value, it's going to be 5 minus 4t. And then we don't have any restrictions on this one. So you would typically say that t is any number. There are some restrictions. So in this case, t is any number. Notice that you have another format where they restrain the domain. This is for other formulas, but they would have mentioned domain from 0 to 1 for the values of t. So this one is perfectly fine. T happens to be any real number. The last portion, it's going to be the symmetrical form. Now, the symmetrical form, you do have to state which coordinate point and vector you're using. And that is because, well, as we have here, notice that I'm using one coordinate point. So there's no reason why you couldn't use the second coordinate point, except that your line is gonna look a little bit different. So for the last one, actually not the last one, but for part C, let me just say that we're using, so using x0, y0, and z0, which happens to be 405. And then the vector, since we're going to be expressing that as, well, in this case, ABC. So the vector V, and we ended up with -2, 3, -4. So -2, 3, and -4. The symmetrical equation now, you're rewriting it in this form. So you're going to put x minus x naught over the first component, and then y minus y naught over the second component. So in this case, it's going to look a little bit different, but we're going to actually rewrite it as x minus 4 divided by -2. It's equivalent to, in this case, well, you just have a y on the top, and then a 3 at the bottom, and then this is equivalent to your z minus 5, and then the third component is going to be a -4. So all of these three are ways of expressing the same line. It's just in a slightly different format. There is one more, and for that one, we're going to go back to part B. So let me double check the last one, c minus 5, and then over -4. Okay, so the very last one, they want us to restrain the domain. Now, some formulas that you're going to use in other classes, they're going to want you to restrain the domain. In this case, it's going to be the same answer, but you're just expressing the domain. It's only from 0 to 1. So it's a very small segment. So in this case, our final answer, it's going to be that, well, x is equal to 4 minus 2t. Your y is equal to 3t. Your z is equal to 5 minus 4t. But we do have to put a disclaimer. And in this case, the values of t are only, I'll just say where t it's only part from 0 to the values of 1. So in essence, here we're restraining the domain. The previous one, when you find the parametric equation of the line, unless you have any restrictions, you typically write that t is a real number. In this one, they only want, well, the values of t to be the line segment between 0 to 1. Okay, that's actually it. And once again, when we're defining lines in space, the lines are associated with a vector. So technically, you're going to have a point in space for a line and then some sort of a vector being associated with it.